And what does this idiot do? He does a completely different experiment where he's got a string coiled up on a on a cylinder, and he's dropping a weight, and then he has a lever tied to that, and then he puts the different masses on, which means that you're going to rotate them in one direction. Okay, it's not going to oscillate. It's not an impulse experiment. It's a adding more and more energy as it falls. It spins, the wheel spins faster and faster. And what are you doing? Oh, we're right back to the whole friction argument. The whole distance this way isn't going up and down, it's going sideways. So sideways, we're right back to the friction argument, where light things have less friction. You know, light things going fast lose less energy per foot to friction than slow things going, you know, things going, heavy things going slow. So a 2 mass and a 1 mass. So a 2 mass will lose more energy to the ground, okay, because it's touching the ground more. There's more contact with the ground, and it's, you know, because of its slow velocity, there's more contact. So not only is there more contact because it weighs more, its slower movement means there's more contact per foot. Yeah. There was no friction in the downward direction. It was only pushing sideways, no friction on any bearing. So when you turn a gear, there's no friction for the weight you have when you're going sideways, unlike his experiment.
Gary. This is how people can know you don't give honest criticisms. If your criticism about friction was actually correct, then the setup with 2x masses on both sides would have moved slower, not faster, because it is the heavier setup. In fact, the setup number 2 with less overall mass ends up moving slower. And setup number 3 with even less mass, with 1x mass at 2x distance on both ends, moves even slower. This is exactly opposite to what your criticism implies. You don't give honest criticisms. I would have been interested in an earnest or honest criticism, but you don't do that. You just waste everyone's time needlessly. You didn't do your due diligence and actually try to think about the experiment, you just threw crap at the wall hoping to see what sticks, and it miserably failed. But by all means, why don't you explain to the world how more weight and friction do the exact opposite of what they usually do? Here is something else you could have done if you had any integrity or carefulness or diligence. You could have noticed that the difference in motion between the two setups existed already before the rods went vertical. Even before the quarter turns were made, you could already see the difference in position and motion. In his response, he says that in the gear example he only talked about what happens after a quarter turn.
Even the gear example, you know, if you were to use a gear, I pointed out clearly in the gear example, you're only doing a quarter turn. You're only converting this direction into that direction, and that's it. You're letting it fly off the gear. You know, so even when I used a circular device, I conditioned the circular device to a certain function.
Okay, so let's review. 1. His argument about friction fails, because the experiment shows the heavier setup speeding up faster, and friction doesn't make heavier things move faster. 2. There is a difference in position and motion of the rods of the setup even before the rods went vertical and a quarter turn was made. With this out of the way, it stands to ask, why does it matter whether the force was applied for a millisecond, 10 milliseconds, 100 milliseconds, 1 second, or 10 seconds? What difference does it make when it comes to examining the relationship between force, torque, and velocity? If you say, you can't tell the difference between the two setups just by applying a force for 1 second, why will that change if you apply a force for 1 second 2 consecutive times? Or 3 consecutive times? You can't say friction, because if friction was at play then the heavier setup would not have moved faster, and even then we could see the two setups deviating even before the rods become vertical. The difference in motion between the two setups is clear. Now let's get to his main argument, that somehow it makes a difference that I had my lever rotate and make full turns with a constant torque applied. But again, how does it make any difference? Your thought experiment where you apply the torque momentarily is just the same as mine but restricted to a narrow time interval. And even then, the experiment I have shown reveals a difference in motion before the rods even have a chance to make 90-degree turns, so your complaint doesn't even apply. You can take my experiment, restrict it to the first 2 seconds, and it would end up equivalent.
Right, so we're talking about a scale, and we're not talking about rotating it, okay? We're not talking about rotating a scale, okay? We're talking about a balance, and we're talking about your pushing on the balance and seeing how heavy the other side is. And the argument remains valid, okay, that if I set up this circumstance with the 2 mass here and the 1 mass out here, you're not going to be able to tell the difference because this part will move exactly the same if the 2 masses here or the 1 mass is out here. This part has to move exactly the same.
A difference is still revealed. We have a balanced lever that starts out horizontal, and we apply a torque, and we see there is a difference between the setups in just the first 2 seconds. If we cut the constant torque at that point, the difference in motion would still be there. There's no way around that. You are the one who keeps asserting no one can tell the difference between the 2 setups just by applying forces, but just applying the force for 1 or 2 seconds is enough, whether it's a gear or a lever. You back up your claim with no evidence, and even worse, you're provably wrong. When you say no one could tell the difference using forces, I, and plenty of people that know basic physics, can do it easily. Remember, I was testing his claim about the relationship between torque applied and the resulting motion based on different mass configurations. It is very clear he thought having the mass and doubling the radial distance would result in the same motion for the same given torque applied. His complaint that this is not exactly the same setup he drew is very superficial, because he was making a claim about the fundamental relationship between torque and motion, and I was testing that fundamental relationship. Will he acknowledge that pressing a lever with a 1x mass at 2x distance is harder, in the sense that it takes more energy and longer time to get the same rotational velocity for the same torque, than pressing a lever with a 2x mass at 1x distance? Because apart from the friction argument, which was shown to be wrong, he doesn't have any argument why my experiment doesn't demonstrate that. Anyways, I wanted to expound more on why this experiment, even if you make all these superficial attempts at distancing yourself from them, debunks the ideas that E equals mgt and E equals mv. For the sake of easier exposition, I will compare setup number 1 to setup number 3, where in number 3 both weights have half the mass and double the distance. In both setups, the hanging weight pulls on the bearing, giving it constant torque. According to Gary, the energy due to gravity is mgt. This means that after the same amount of time, we should see the same energy put into the setups. Okay, so at time t, setup number 1 and setup number 3 have the same energy. Now the bearing and rods of the setups are the same. However, the weights in setup number 3 have half the masses and are at double the radial distances. This means that if energy were E equals mv, then we would expect the entire setup to have exactly the same rotational velocity, as the weights would have had half the masses but double the velocities, yielding exactly the same total energy. But this is not what we see. Setup number 3 lags behind, and the reason it lags behind is that for the same energy, having the masses for the same energy does not double the velocity, and you can see this in the experiment. Thus, this experiment overall is inconsistent with Gary's E equals mv and E equals mgt nonsense. He can continue to spout it, and at the end of the day all it will show is that he is no better than any flat-earther who repeats debunked lies. Everyone is free to repeat this experiment, or do any variation they think is fit, and it would be interesting to see what results others obtain. Thank you for watching, and please don't just take what Gary says on face value or faith.